First of all, I would like to apologize for the delay. We were supposed to publish the course yesterday. All the recording is done. That's the good news. However, due to a severe cold that I'm recovering from right now, we were behind in the recording, and that has led to some delays in the editing as well. However, here's a teaser for the syllabus, the exact syllabus that is already recorded, and this is what will be available in the next few days to you. What we are going to do is, as we finish each section of editing, we are going to publish it on dolphined.com. So you will have access to that as we move along. And I think within 5 to 7 days max, the course should be ready 100% after editing and final touches and all that. So this is going to be the syllabus of everything that made it into the course. And I have to admit, not because it's my course, but I have to admit that I haven't found any other course that have taken the same approach, which is blending the fundamentals of IT, starting from the very beginning, from the true ground, and coupling that with AWS Cloud, the basics of AWS Cloud, and practicing in the AWS Cloud. So you are not only going to learn the fundamentals of computing, the fundamentals of networking, the fundamentals of network security, but you will also apply that in the cloud. So you are not logged in, not like A+ and Network Plus and CCNA that you have to practice on Cisco. What if I will never use Cisco? What if I don't want to become a network engineer or a network security engineer? Then all the practice is going to be wasted. Now, this is on AWS Cloud, the largest market share cloud provider. It will show you what the cloud is. It will give you a feel of what the cloud is. And after we do this, and after we do all the practice in the cloud, we are going also in the course, I'm going to take you and teach you at a high level what is Linux, and we're going to do some Linux exercises. What is Bash scripting? So you understand why do you need to learn it? Where does it fit in your role, in your future role, I mean? What is Git? What is GitHub? And what is infrastructure as code or Terraform? Also, what is Docker and what is Kubernetes? So this course, I wish I had something similar to it when I started in IT. Something that will save me a lot of time. I would 100% say that this is the best entry into IT, the best entry course into IT. And that foundation that this course will give you is going to help you no matter what your specialization or specialty in IT would be. And even if you decide to go after that and do Network Plus and CCNA because you love networking, this course is going to make your learning through these courses much, much, much easier at a fraction of the cost. So without further ado, let me walk you through the exact syllabus that you're going to find in the course. But before I leave you, please, if you haven't, subscribe to the channel, activate notifications to receive more topics from this course that are going to be published over the next few days as a teaser and as also a way for you to find out what the course is about and what's the quality of teaching, what's the quality of the hands-on and stuff like that. All right, let's go ahead and check the accurate and final syllabus of the course. All right, let's get to know the syllabus of the course. What exactly we are going to learn in this course, module by module. There are 12 modules, so let's quickly go through them, and that could be a reference for you as well. Anytime you would like to find out which section has what topics, if you would like to reference them quickly. So this is going to be your reference. So let's go ahead and start with module number 1. So in module number 1, we are going to introduce important IT concepts. And in this module, we're going to cover what are the computing device components. Your phone, your tablet, your laptop, your server. What are the common components that we care about? We're not going to cover every single component, of course. The ones that we care about and we are going to use throughout our learning, disregarding which career roadmap or career direction you are going to take. Then we are going to learn about software and OS overview, operating system overview and software. Then we are going to learn about software applications. What are they? That will take us to module number 2, where we are going to introduce servers and virtualization. So we're going to go back from hardware We'll go to software in module 1, and then now we are going to come back to servers again, which are hardware. But of course, understanding that they require software to run. We are going to talk more about the servers, and we are going to introduce a concept called virtualization and why virtualization emerged, and were there any limitations about servers that led to the emergence of virtualization. So we're going to learn about physical servers, virtualization overview, what is it, and that will take us to module number 3, where we are going to introduce data centers and cloud computing. So if we're going to launch our applications on virtual machines using virtualization or physical servers, where are we going to host them? Where are they going to be physically located? And this will be in data centers. And then we are going to take it from there to introduce what cloud computing is. So we'll talk about data centers. What are they? I'll show you some images about data centers and how they look like from the inside. And that would take us into cloud computing. And then we will know more about cloud in general by identifying or introducing the services models that are common in cloud computing. We'll take it from there into cloud deployment models, how you can do private clouds, public clouds, or you can do hybrid clouds where you connect a private and a public cloud. Then we are going to take it into which cloud provider to start your learning with. Do you go with AWS? Do you go with Azure? Do you go with GCP? And why? That will take us to module number 4, which is networking fundamentals. And this is where a lot of people get stuck. And a lot of people think they have to go and do A+ and Network Plus and CCNA. You don't. This course is going to introduce you into networking at the right depth, where you can straight away start your cloud computing or any career roadmap that has or requires networking fundamentals. And even if you decide to go into network engineering, that's fine. This is going to dismantle a lot of the complexities. So even if you decide to go with A+, Network Plus, and CCNA afterwards, you will be able to understand the concept very easily as far as networking, IP addressing, routing, switching, and all that go. So we'll identify what is a network, and we'll talk about the network types. We're going to cover the local area network, the wide area network, and the wireless local area network, or the Wi-Fi LAN that we have in our offices and homes. Also, we're going to look at the types of network traffic. What types of network traffic? Unicast, multicast, broadcast, what does it mean? And then we're going to look at what devices do we use in our networks. We are going to start with wired network devices. And from there, we are going to talk about network cabling. These physical devices, how can they connect servers? How can they connect laptops? How can they connect to the internet? We need to understand the actual wires or cables that we use as well. What are the options? And from there, we are going to leave the wired a little bit and then go into the wireless realm and talk about wireless access points and wireless routers. From there, we are going to look at the data center networking. What is a data center compared to a local area network? How does it connect to the internet? How does it connect to another data center? How does it connect to a local area network? All of that we are going to look, and everything has a lot of visuals, so it will be very easy for you to assimilate and comprehend the concepts. Then we are going to look at something called campus area network, or CAN. This is when universities, or maybe a huge hospital with several buildings in close vicinity or in one common area, big piece of land or plot of land, how do they connect to each other? How can we apply LAN into a CAN, for example? And we'll put all that together and introduce what is the internet and how does it look like from the 50,000 feet perspective. That will take us into module number 5, where we are going to dive deeper into networking with IP addressing. And to be honest, in like 10 years now teaching cloud computing, automation, DevOps, and even authoring and co-authoring a lot of courses, this is where a lot of people get stuck. IP addresses, subnet masks. How can you take a range and break it down? What is a subnet mask? How can I understand it? You know what? I'm just going to use online calculators. It's way above my head and I can't understand it. We're going to explain it in layman terms, step by step, until you understand it very well. It has a slight or a small component of math that you can ignore if you don't want to understand it, because we are going to introduce the online calculators, but also we are going to explain it, the bits and pieces, so you would understand it in an easy way. So we're going to look at what are IP addresses and why do we use them, and how does an IP address look like, what are the different versions available. We're going to do a little detour to contrast the numbering systems, the binary that is used inside the computing devices, to the decimal that we all know. That would help us understand the details when we get to it. And then we are going to look at IPv4 addresses. There are two versions available of IP addressing, IPv4 and IPv6. We're going to introduce IPv4 and then dive deeper a little bit to introduce hosts and networks. And then we are going to look at subnet masks. And from there, given a subnet mask, how can we practice and find out the network ID, the host ID, the subnet mask, and in binary and in decimal as well. And we're going to look at the IP address classes. What is a class A? What's a class B? What's a class C? How would I know? Looking into an IP address, how would I know if that's A or B or C? And then we are going to start, when you get the crust of the pizza, the full pizza, how can you divide it into slices? When you are given an IPv4 address range, how can you divide it into subnets or subnetworks, basically? So we're going to learn it through the calculators, the easy way, and then we are going to start breaking it down our own hands. So we're going to be given an IP address and see how we can break it down and find out the usable IP addresses. What is the first IP address or the ID of the subnet, which is the broadcast IP address. We are going to learn all of that. And then we're going to look at detailed subnetting. How can we do it? So the calculators, what is the logic programmed into the online calculators to break down a range into subnets and to find out what's the first IP, last IP, the usable ones, and the subnet mask and the network ID and so on. So we're going to learn that step by step. And again, if you are not getting into this course because you want to become a technical person, you just want a high level overview, you can just ignore this IP addressing detailed part, because if you are a program manager, a director, or maybe a project manager, you won't do that your own hands day in and day out. But if you are going to be a cloud engineer, an MLOps engineer, a DevOps engineer, SRE engineer, platform engineer, any one of these, or even a network engineer, you need to know the details, even if you will end up at the end using the online calculators. Then we are going to give you some subnets for quick reference if you would like to start learning other technologies, or you start in your career learning after this course without having to go back and memorize how you can break down a subnet into or a range into subnets. Then we're going to look at what are public IP addresses. What are the internet acceptable IP addresses that can appear on the internet and the internet can get to them? And what are the private IP addresses as well? If I'm in my home and I would like to use a printer like the one behind me and wireless network and maybe connect my mobile phone, iPads, and so on, how can I deliberately, without any permissions, decide what IP addresses to use and then configure them inside my home? And now if I would like to get to the internet through my phone, for example, what would do the transition from private to public? We are going to understand all of this. This would take us into module number 6, which is about IP routing or IP routing. So if you understood what IP addresses are, and by the end of module number 5, you will be capable of designing an IP scheme given some requirements. So for example, there will be some practice assignments where you will be given a range of IP addresses, a block of IP addresses, and you will be requested to break it down into 6 subnets. Then you are going to do this, and you will be given, okay, each subnet must have this much of usable IP addresses and this much as a spare for future. So you will need to know, and you will be capable of breaking that down into an IP scheme that meets the requirements and has future spares or sparing or scalability built within the IP scheme. So this is something you will be able to do it at the end. We'll take it from there and start to talk about routers. Now, within the data center, within the local area network, if the local area network would like to get from one branch to the headquarters, and it's going to cross a wide area network, how can that happen? So we're going to look into that as well. And then that will include, how does the IP routing work? What is an IP packet? The message that we send from one device connected in India on the internet to a server, let's say CNN.com in the US. What would the message look like? This is called an IP packet. And then we are going to take that and start applying on AWS. So we need to understand what AWS is. What's the global infrastructure in AWS look like? And we're going to look at the AWS VPC overview. Building a virtual data center in the cloud, in the AWS cloud, is called a VPC. So what is it? What's the VPC? We're going to start looking at the components of a VPC. What are the subnets within a VPC? What are the route tables that we can configure in a VPC? What's the implied router in a VPC? And more components for the VPC that we're going to learn, because now we are building a virtual data center in the AWS cloud. So we need to understand the ins and outs of that data center. From there, how can we connect our virtual data center to the internet? So we need an internet gateway to help us connect that. How can we create one? And how can we attach it to the VPC or connect it to the VPC? And all of that is going to be hands-free. You will only click some buttons, and I'm going to show you how easy that is. We are going to click some buttons and then magic happens, and you'll find that your VPC is connected to the internet. And we are going to launch virtual machines, and we'll connect to them from my laptop through the internet to the AWS server, which could be in Germany or in the US, and it will work like charm. Then we are going to look at how we can launch public IP addresses or subnets and private IP addresses or subnets in our virtual data center, and why we would do that, or we would want to do that. And then we'll look at the conversion from private IP address subnets into the internet or public IP address networks. How can that happen? And we're going to introduce what is called network address translation. And how does it work? And we're going to show you how that works. And then we'll look at IP packets and the headers. When you send a letter from one location to another, you need to find out exactly who is the sender, who is the receiver, the stamp that is on the letter or the envelope. But these are all not the actual message. The message is a piece of paper with what was the intent of that message inside the envelope. So that's called the payload. So we're going to start talking about payloads and headers, and what are the function of the headers, and what are the essential headers that have to exist into an IP packet for proper delivery end to end. So we're going to take that and tie it back to IP routing. Then in module 7, we're going to look at, okay, are there any reference models? Are there any standards for networking? And that will take us into finding out what OSI reference model is, what's the TCP IP protocol reference model is, and what are the protocols or common protocols that we are going to bump in frequently into any career that we are going to use, as long as it has hands-on and engineering involved, or even if it is architecture at the end, you will also need to understand these concepts. So we're going to introduce the OSI reference model, the TCP IP protocols, and that will include ICMP and SSH. Don't worry about the names now. You're going to understand these very clearly and very easily. HTTP and HTTPS, which we use it every day when we connect to our banks through the browser or websites on the internet. We use HTTP and HTTPS, even if we don't know. And we're going to look at the anatomy of the IP packet. So now, knowing all of this, how can we tie it back to the packet again and look at the headers and look at the payload and all that stuff? And this would take us into module number 8, where we're going to introduce cybersecurity and network security. So knowing what cybersecurity is and what are the different specialization or branches within cybersecurity will make it easier for us to categorize network security as a branch within. So you are not going to confuse the word cybersecurity with network security. Network security could be a career on its own, but cybersecurity is more encompassing for a lot of different specialties, including network security. And when we focus on network security, we're going to introduce or come back to networking devices, and firewalls are one of the common networking devices or the devices that we see in networks, although the primary reason for having them is going to be security or network security, not to do the networking part. And I'm talking about simple firewalling here. So firewall examples, we are going to look at AWS security groups, which is a virtual firewall available for every virtual machine launched within AWS. So we're going to look at that, and you are going to understand how you can configure the different firewall rules to stop certain types of traffic if you don't need them, or allow others if you need them. And then we're going to look at another example at the subnet level, not the virtual machine level, which is called network access control lists, or abbreviated NACLs. Now, sending our traffic within the AWS cloud between the application and the internet, for example, how can I secure that traffic? How can I cipher it or encrypt it, as we call it? How can I put it in an ununderstandable, ambiguous, unclear, scrambled format where if a man in the middle or someone spies or is able to copy that data, they will not be able to understand it? That is called encryption, encrypting your traffic. And this is very important, whether you are sending the traffic over public networks or even when you are storing the traffic in your databases or your storage in your infrastructure, you have to look into encrypting that traffic just in case. And encryption will make it easier for us to introduce something called virtual private networks. If I'm connecting my data center to the cloud, and there will be a lot of communication between applications and databases across. Don't worry, we're going to understand what applications are and what databases are as well. So if that communication is happening over the internet, how can I encrypt that traffic? How can I create a virtual tunnel on the internet such that nobody can understand what's the text that's being transmitted between the two sides? Only the two ends will be able to understand that. That will take us into module number 9. When I type in my browser www.cnn.com, if we agreed that everything on the internet and everything in IP is about IP addresses, now who is going to translate that? Who is going to take the cnn.com and translate it into the right IP address on the internet such that that packet or that message can be sent? And that is what we call domain name systems or domain name servers or services. Whatever the name is, it means the translation between domain name, cnn.com is a domain, and IP addresses basically. And introducing that, we are in a very good position to think about, okay, fine. Now, when I'm sleeping at 3 o'clock in the morning, if something wrong happens within my infrastructure, how would I be alerted? Do I wait until the users find out that my e-commerce website is down and then they start launching support tickets that they can't order or track their orders or cancel their orders? That is reactive. I will know after the users, and that means users are going to be disappointed and bad reputation could start to arise about my company or my e-commerce website if this repeats. It's better to know before them or at the same time so I can launch the right engineers to look into it and fix it very quickly so we avoid the bad reputation. We hopefully fix it before the users will know about it. And that means we are proactive, not reactive. And that's why monitoring and notification or alerting and also archiving the events that happen within your infrastructure is very important. And this is true no matter what you do. If you are doing DevOps, if you are doing platform engineering, cloud engineering, network security, cybersecurity, you need to have information about events that happen in your infrastructure archived. So they will be helpful for auditing. They will be helpful if we find out that for a specific bank, there were some wrong transactions done. How can we know about them? We have to have logs, right? So alerting, monitoring, and logging at a high level needs to be understood for anyone who's getting into IT and why they are important. We can't finish this journey without introducing what databases are. So database is the persistent storage. This is where when you go onto Amazon.com and you purchase some products, then you can always reference it. Even if it is after 3 months or 6 months, after it has been delivered or refunded, you can look at the history. Where is that? It has to be in a store that doesn't lose the data, even if something wrong happens within the infrastructure, there has to be copies of that data, and the server should be resilient and all that stuff. This is called persistent storage. So databases are the persistent storage that we use for the data that has to do with orders and customers and patients and so on. And we can't finish talking about these core modules without you being capable or training you on how you can draw a professional looking architecture or design document. In your interviews, you will be requested to solve an assignment, and then you need to send it back in a document. So they will look at how you can write documents, how do you structure it, and the drawings that will aid the understanding of the document, or what your solution is, what your architecture is. And it shows that you understand what are the critical things that has to appear. So which tool to use? We're going to walk you through an example VPC with a lot of things that we have learned throughout the course, including databases as well. And we are going to draw that with you from scratch in order for you to understand how you can do it and how it should look like and what tool to use and how you can put the different cloud icons and so on and so forth. So this is going to be how we are going to finalize the core parts. Now, in Module 10, we are going to introduce modern architectures, and we are going to look at some tools and technologies that are very critical in modern IT. Disregarding whether you'll end up doing cybersecurity, network security, data science, data analysis, machine learning, AI, or cloud or DevOps, or whatever the career that you are going to use in the modern IT realm of roles or realm of jobs and specializations, you need to understand the modern architectures of applications, and these tools are very critical no matter what your decision would be. So we're going to introduce applications, how they were built, which we call the monolith, and how the microservices architecture, which leads into what we call later the cloud native, are, and what's the differences and what are the advantages and so on. So we're going to introduce containerization, Docker. If you have learned the terms Docker, what does it do? Why do we use it? Why do I have to learn it? And how is that different from physical server and virtual machines? And why is it gaining popularity? And why they are saying it's very fast and cheaper and cost effective and so on? We are going to introduce that, and we are going to do some hands-on on it. And if we want to deploy and manage a large-scale containerized infrastructure, then how can we centrally deploy, monitor, repair, and maybe destroy as well if we don't need the infrastructure? How can we do all of this? Through an orchestration and management tool, and Kubernetes shines when we talk about this. But also we're going to show what's the alternative of Docker and what's the alternative of Kubernetes that's also popular or gaining popularity. Then we're going to move into, okay, we talked about operating systems. Can we do a little more with Linux? Can we introduce what bash scripting is and why it is important and how can it help? We're going to look at VCS or version control systems, and then we have to introduce what Git is, and that would take us to collaboration on the internet between different team members, and GitHub is key. And you will understand why do we use it? What are the use cases? How does it tie back into bash scripts? How does it tie back into Kubernetes? How does it tie back into containerization? Into coding if you're a developer? Why is GitHub important to share and collaborate with other developers in your team while you are working on solutions and applications and so on? And when we talk about the cloud and deployments in the cloud, then infrastructure as code jumps in. It's very critical and very important to understand, and we're going to go through Terraform and understand why that is important. This will take us into Module 11, and Module 11 will introduce us to a lot of career roles that are in high demand, and they pay very well nowadays. And that will take us into what DevOps is, marrying development and operations, what site reliability engineering is and how is it different than DevOps, and also the newest trend, which is platform engineering. To understand these, we have to understand the software development lifecycle, because all of these jobs have to do with automation, lessening the intervention of the human factor in software development. So we need to understand software development lifecycle, or SDLC. We're going to look at the SDLC models, and this is where we are going to introduce waterfall and agile. And from there, we're going to introduce DevOps and how is it different. And then we're going to look at CI, continuous integration, continuous delivery, and continuous deployment, or the famous CI/CD. And then we're going to look at DevOps tools that tie back into all these careers. And a very important question that will always pop up: do I have to be a developer to become a DevOps engineer or a site reliability engineer or a platform engineer? And the answer is, it depends on which school of thought. Some school of thought think that yes, you have to, and others would think only fundamentals are enough. So we're going to break that down as well. We're going to dive deeper into SRE, or site reliability engineering, and platform engineering. Then we are going to introduce what cloud native is and how does it tie back into DevOps and cloud and containers and Kubernetes and all that, and Docker and all that stuff. And how can we secure this? So if you are into DevSecOps, that means if you are deploying in the cloud, how can you secure the cloud part that will hold the application, but also from the time the developers submit their code until that becomes deployed in the cloud? How can you secure that end to end to make sure that your code is secure? You scan your code, you make sure that it doesn't have any bugs or problems or back doors that can be used to break into your applications. And also, how can we secure it and give the right permissions in the cloud? And last but not least, we are going to look at career coaching for beginners, and that will be in module number 12, where you are going to look at the different careers you may think of after this course and the next learning steps based on where you are going to head next. All right, so this is our syllabus. It's very rich. It has a lot of hands-on in the cloud, in the AWS cloud. So you will learn IT fundamentals, network fundamentals, security fundamentals, different careers, and also you'll learn the cloud fundamentals, so you know at the end what IT would look like and what the cloud would look like as well. And if I decide to go into network engineering or DevOps or site reliability engineering or platform engineering or cloud engineering, what are these jobs all about? And also development and so on. All right, so hopefully you are ready. I apologize for the length, but this is going to be your index. This is the reference where you can find anything and which module has it. And of course, you can use also the PDF that is attached to the course. So either way, you have all the details, and hopefully you are ready right now. Get your cup of coffee and let's jump into module number 1. Hopefully you like it. Hopefully you think that this is the course that you have been looking for. And honestly, I think this would be your best investment at the beginning of your career in IT. It will not only teach you fundamentals of IT, but cloud and many tools at a high level, and network security and cloud security all combined together in one course. And as you have seen at the end, there is a bit of coaching, so it can guide you through what are the roadmaps that you can go through and how can you pivot into one for some time and then move to others once you have settled and proved yourself. Okay, so stay tuned for the announcement of the course in the next couple of days. And I do apologize again for the delay, but unfortunately, genuine viruses at this time of the year don't distinguish between who is busy and have deadlines and who doesn't. Thank you again for your patience, and I'm confident the course is going to be up to your expectations.